Okay, so our next slide is basically introduction to network technique. Okay, network technique, and we will introduce the term and terminology in this slide, and then later on in the subsequent class, then we will zoom in into the activity on arrow, and then AON diagram, PDM diagram, and then later on I will show you demonstration on how to use Microsoft Project, etc., etc. Okay, network technique historically was developed in the mid 1950s. All right, it starts with AOA diagram, then PERT diagram. Okay, this is 1950s. Then 1960s, AON diagram. And then subsequently, PDM diagram was being developed. Okay. And you know what? People who develop this diagram, it is not a common people. No, no. They are, PERT diagram was being developed by engineer. I think Henry Gunn was mechanical engineers. And then AON diagram was developed in Stanford University. You see, it is not a common people who develop this thing. They are people who basically just trying to make things easier at the beginning for themselves, but later on, if found that it is very helpful, then everybody start using those things. Okay, so you can read the history just by Google. I do not want to go into detail. Advantages of network scheduling, network technique. Comparison between network technique and traditional bar chart has shown many advantages over the latter. The advantages include show the critical path. Okay, critical path. Remember this terminology, critical path and critical activities. Critical path, the way you read this statement is basically critical path and critical activities. Okay, this is very important. Without network diagram, then basically we do not know what are the critical activities, what are the non-critical activities. Why do we need to know critical activities, especially with regard to resource planning? When we are in conflict, for instance, we do have two activities running at the same time, and that activity require the same resources, so that resources cannot go working at one place and then at the same time, two places at the same time, and then the issue of priority. Where are we going to give the priority to? This is where the critical activity and non-critical activity will play very important part. Okay, that's what we need to know. Optimum project cost. Okay, Op optimum project cost, or simply say minimum project cost. Optimum meaning to say the best option that we have. And I already mentioned to you, a good scheduling should be you try to do everything, fulfill all the objective of the planning at the lowest possible cost. Then only you can get the most profit. And not everybody can do that. Only creative or dedicated, I would say, scheduler or people who understand the work can achieve those things. Okay, it requires a lot of work experience. Fresh graduate might not understand the whole concept. You can do the scheduling, but not to the extent that you can get to the optimum cost. Determine the extension of time. Rescheduling is very important. Rescheduling, or what we call revised plan. Revised plan. The plan might not be working as what you wish. Never mind. You have the opportunity to revise the plan as long as the project is still have time. Okay, activity on arrow. AOA. So again, this is just revision. How do we draw AOA diagram? Okay, start with the node. Make a big circle there. Then one arrow followed by arrowhead. This is what we call the tail. This is arrowhead. Okay. And then the activity is written on the arrow. That's why AOA is named after. Okay, that would be then close by one notes. So the whole thing here indicate an activity. Indicate an activity. Then, if you want to connect to another activity, then you already have the nodes, the existing node. Then simply the arrowhead will go into the following nodes, and you know this node will be filled with values. Let's say 1, 2, 3. 1 to 3 indicate the node numbering, whereas the space inside this node I can fill with something. How to calculate this thing? Let's assume activity A is 5 days, activity B is 4 days. You see, I will start with 0. 0 plus 5 equal to 5. 5 plus 4 equal to 9. You see, 9 is basically the end of the project. End of project or project duration. That's why at the end of the day, later on, you will fill up all this spacing, the space here, with number, because that number has what we call indicate something. Okay, that is our intention toward the end of the learning. Okay, so the good arrow diagram should start with one arrow, one node, sorry, and then branches out as many as activity, doesn't matter, but the concept is almost there. You start with one node and close with another one, and then see, and then you could be here, doesn't matter. Okay, then whatnot here, and then for instance here. See, start with one node. This is start, and then this is end. This is what we call network diagram. Network diagram, as the network name normally imply, it is like a spider web. You know, spider web is basically all interconnected. Okay, then only we call it a diagram. Otherwise, you do not basically get the what we call, at the end of the day, we are going to generate so-called critical path. Critical path you simply cannot get when you have a node or activity which is not connected with something else. It must be connected like a closed loop. Okay, activity on node. Activity on node, remember the node in the original design was circle. Like what I draw here, the original design was circle. If we continue using circle, then people will get confused. Is it activity on node or activity on arrow? Later on, even you yourself, if for instance, if we give you test question or exam question, let's say the test question asks you to use, we do not ask you to use either AOA or AON diagram, but from the question you basically know which drawing is the best to be used. Okay, so you will get confused by drawing AON diagram instead of drawing AOA diagram, you see. But don't get confused. Once we draw them like a square, that indicate the nodes and activity on node is being written inside the box. The arrow is just simply to describe the relationship. So between this slide and this slide, they are the same. Two activity, activity A and activity B. And you notice that because the box basically do have a lot of space that we can put inside like this. Okay. And you can basically go to British Standard. British Standard is the one that we use previously. Now everybody using Eurocode for UTM, but not outside there. Outside there, still using British Standard. If you Google British Standard, there is a even a guideline or standard to draw the PDM diagram. How to draw the box? What could be the legend inside the box? So the legend inside the box indicate this is the early start, early finish, late start, late finish. And then this one is total fluid values. And this one is the duration. Let's say, as in our example, duration is 5 days. This one is 4 days. And how do we calculate? 0 plus 5 equivalent to 5. 5 then transfer here. 5 plus 4 equivalent to 9. You see, the project completed in 9 days. Similarly, in this diagram, 9 days. But the graphic looks different. But in terms of the concept of calculation, they are the same. You should get the same answer. But nowadays, this is what we call AON or even later on PDM diagram. PDM diagram is being used in Microsoft project. So MS project and Primavera basically use this type of diagram, PDM diagram. And AOA diagram, there are software that basically use AOA diagram, but for learning purposes, we do learn about those things. But in reality, once you use PDM diagram, it is sufficient enough. Okay, no need uh, to use AON diagram. But for learning purposes, we just simply going to learn those things a little bit. Okay, because for simple network diagram, which basically do use a finish to start relationship, drawing using AOA diagram is sufficient enough. Okay, all right, this is example. Okay, this is example A, B, C, D, E. Okay, A, B, C, D, E. You notice these two examples are exactly the same. Okay, exactly the same network diagram, but except the way we draw. Okay, you notice there are A, B, C, D, E activities, and it shows the relationship. Okay, A as the activity A. How do we draw? We simply draw something like this. Okay. Okay, we draw something like this. A. Okay, this is A as an activity, and the duration is being shown there. Okay, and then after A, there are two activities that follow, three activities that follow A, B, C, D. See, for AON diagram, we just simply draw a box here, B, C, D, and then connect them by arrow. Arrow could be just a very short arrow, doesn't matter. You just want to show the relationship. After A completed, then activity B, C, and D will basically start. And similarly, you see, you notice the way the arrow now for AOA diagram reflect an activity. See, reflect an activity B, C, D. But then, how about E? Okay, activity E simply say based on the relationship, E will start after B, C, and D completed. B, C, and D completed. Okay, we already draw for AOA diagram. We already draw arrow here, arrowhead, And then after C completed, then we can draw E. But the equation say E will start after B, C, and D completed. And then how are we going to connect those things? That's why we need to use what we call dummy activity. The dotted line indicate dummy activity 1 and dummy activity 2. This is what we call dummy. We will go into this one, dummy activity. And you notice that for AOA diagram, the diagram could be later on could be more complex in order to accommodate many dummy activities in order to show the right relationship. Whereas for AON, the diagram itself is very simple, straight to the point. That's why PDM, this is simple AOA diagram, but later on, it developed into PDM diagram. That's why PDM diagram is being used in MS Project and Primavera. So if you learn about PDM diagram itself, then it is sufficient enough because it is more, basically everything is there. Avoiding terminology confusion. Traditionally, networking technique has been referred as CPM, okay, critical path method, and then AOA, and then PDM diagram. Okay, critical path method. What is critical path method? Critical path method is the method of calculation. Method of calculation in order to generate so-called critical path and then critical activity. Okay, if you go through this slide, what is critical path? Critical path is basically the longest, the summation of the longest duration in a network. Later on, we will show you what can be considered as a path. Okay. All right. So we do have here example. If you look at this diagram, automatically when there is a box and then the activity is being written inside the box, this must be a AOA diagram. Okay, AOA diagram or PDM diagram. Okay, you must understand. No, AON, sorry, AON diagram. It is not AOA diagram. Okay, you notice that the word path mean the line, the connecting line of activity from the beginning of activity until the end. For instance, if you look at this diagram, you will notice there are 1, 2, 3, 4 paths. Okay, 4 paths. You notice A, B, E, H, J can be considered as one path from the beginning until the end of the project. A, then B, then E, then H, then J as one path, number one. Number two, A, B, F, J as one, another path, the red one. Number three, the straight line AC, C, F, J. And the last one is AD, the bottom line there, AD, G, J. So you notice that in this network diagram, there are 4 paths from the beginning until the end. To reach the end of the project, you must go through 4 paths. And 4 paths. If you calculate how long it will take each path to complete the project in that path, how do you calculate? For instance, A, B, E, H, J. you just simply add these 3, that will be 8, 14, 16, plus 10, that will be 26. 26. This one is 27. This one is 5, 14, 24. And the last one would be 4, 6, 4, 6, 16. You see, there are 4 different paths, and each of the paths have a duration it will take in order to complete all the activity within that path. And you notice that the project will complete, there are figures inside here, in 27 days. This is the overall project duration. This is project duration. And in our class, you must be able to draw this diagram based on the information given. Okay, first thing, you must be able to draw based on the information given. We just simply give you information based on listing of activity, duration, and then relationship. Then from that, you must interpret what does relationship mean, and you must draw accurately. So after you draw accurately, then you will fill up the figure here, this figure, the top of the box and bottom of the box until the end of the day. You complete all. So once you complete all, then you will get the first answer as we want inside the exam or test. We will ask how many days required for this project to be completed. So the answer is 27 days. But sometimes we are not going to ask you directly with that answer. We want to know the date when the project can be completed. Assuming perhaps Sunday is the holiday, let's say, is non-working days, and then the project will start on, let's say, tomorrow. Tomorrow will be Thursday. So tomorrow would be 12th November. So every Sunday is non-working days. So if you take a look at the calendar, 27 days, meaning to say, is working days, solid working days. We do not deduct the non-working days yet. But if your calendar of work basically require every Sunday is not working days, then you will know what would be the date after 27 days from tomorrow. That is the answer that we want. So if you can answer those things, then that will be the only one answer. Then question number 2, subsequent question. Because normally in order to draw this diagram, it will take some time. So it is not worth just simply ask one question. So we do have subsequent question, maybe 3, 4, 5 question. Okay, number 2 question, very popular question. What is the critical path? Or even how many paths does this diagram have? Well, if you know there are 4 paths. Among those paths, they could be critical path. And what is the definition of critical path? Is the longest summation of the duration in that particular path. And what is the longest summation of a path? Which is basically equivalent to path number 2, the red in color, 27 days. And why do we call that critical path? Because that path determines the project duration date. You see? That's why it is critical. And why it is critical? When the total float, there will be another terminology, total float, we call it TF, equivalent to 0. And you notice that how to calculate TF, we will go into that thing later on, but just simply, we already have this diagram. TF is the difference between this value and this value, or the left side, this value and this value. You notice that 27 minus 27 equivalent to 0. Here, F, 17 minus 17 equivalent to 0. B, 8 minus 8 equivalent to 0. And A, 3 minus 3 equivalent to 0. When TF equivalent to 0, meaning to say that activity we can consider critical. When critical activity are interconnected together, they are being called critical path. Whereas activity which basically do have total float value, example H, 17 minus 16 equivalent to 1, 15 minus 14 equivalent to 1. What else? C, 8 minus 5 equivalent to 3. And then 14 minus 3 equivalent to 11. This one equivalent to 11. You notice that when total float do have values, they can be considered as non-critical activities. You know why? Because they do have free time. How many free time do they have? For instance, activity H is 1 day. Activity E is 1 day, but that 1 day is being shared together in one particular path. So that's why we the definition for critical and non-critical is the issue of whether that activity do have free time or not, which can be delayed, or if something happen, it can be extended or not. Okay, that will be the critical path. And based on this terminology, because since you are learning a new thing, you might not get confused. But for all old people, okay, for all old people, remember, they start learning AOA diagram. Then only PDM diagram come into the place. So they always associate AOA diagram as CPM, critical path method. Whereas critical path method is the only calculation method. In order to apply those calculation method, you can apply them in AOA diagram or even in PDM diagram. See, the differences is that one is meant for calculation method, and then the diagram is just meant for the graphic representation of the what we call scheduling technique. Okay, so we completed on those things. Basic component of network diagram, network technique or diagram. We must have activity, or in computer software, they call it task. They do not call activity. Okay. In Microsoft project, they call it task. Remember, Microsoft project was not invented for construction industry. It was invented for many industries. So yeah, so that's why they use task instead of activity. Logical relationship between activity and is known as predecessor versus successor. Okay, logical relationship is known as predecessor or successor. What does that thing mean? Okay, predecessor. Let's say we do have one activity A, B, C. The predecessor mean what activity come before the activity that you refer to. Let's say activity A. What activity come before? Before mean when we draw a drawing, we draw from left to right. That's the way to draw the drawing. So if we look at A, what activity come before A? Basically none. So how to put those things in terms of relationship? This is A, B, C. This is what we call activity. This is what we call predecessor. This is what we call successor. Successor is just the antonym of a predecessor. So by default, all computer software basically use predecessor type of relationship, whereby you can basically use successor. I found successor is much easier to relate to, but anyway, that is the concept. Okay, let's say from this diagram, what is the predecessor of A? It's basically none. What is predecessor of B? Okay, if you look at B, what come before B is basically A. So that's how you write A. And then C, what come before C is basically B. And then that is one way of looking at things. Normally, this is the information given in the test or in order for you to draw the diagram. If you have this information, then basically you can start drawing the diagram. But then there is another way to put the predecessor instead of predecessor, successor. Let's say successor is the one that comes after that activity. For instance, what comes after A is basically B. What comes after B is basically C. And what comes after C? Basically none. See? There is another way of drawing. So that's what we call logical relationship. And then arrow. Arrow is the one that basically relate one activity and another. I think we do have later on the definition of relationship later on. And then the nodes is either the square one or the circle one, and then the critical path. Okay, when you want to draw network diagram, all these components must be there. Activity, what is the activity? Activity is the breakdown of smaller component of project. Let's say you are being instructed to build a house. A house by itself is a big thing. It consists of so many activity inside. So how are you going to measure the progress of your work if you do not break down into smaller portion so that you can tell people now you already completed the ground beam, for instance, and then people can imagine, oh, okay, uh, based on your description, then people can imagine how long it will require for you to complete the whole works. Okay, for instance, in the network diagram, the activity can be denoted by the naming of either A, B, C, or you can put proper name. And then normally when you draw a network diagram, you even though you already know that C, D, and A start at the same time, these are the starting activity, but you can include start as a milestone activity. Milestone activity. Milestone activity. It doesn't have any duration, but it just indication of the important event when the whole project is going to start and then close by the finish activity. Type of activity. Okay, you can name the activity as production activity, whatever activity, and milestone is the important event. Important event. Normally, we relate to start and finish of the project. Okay, that's what we call milestone. And then dummy activity. Dummy activity is a activity. Okay, it's a fake activity. It is just for the sake of fake activity that normally we use in AOA diagram to indicate relationship. Okay, to indicate relationship. Okay, WBS, work breakdown structure. Work breakdown structure, WBS, can be defined as the breakdown of activity into a smaller unit which is more manageable or can be measured so that you can delegate the work to the right people and can be divided into responsibility, distinct structural element, location of the project, category of work, and then with regard to breakdown of the work for bidding purposes, sometimes for bidding, even substructure work or the earthwork or even the superstructure, and then M&E work can be divided into different contractors. So WBS can be broken down into that kind of category, and then payment purposes, especially accounting system. Okay, this is the example of WBS. You draw using a tree, what we call tree diagram. It is like organization chart, but organization chart is for people. You want to break down people into a unit, section, etc., etc. But now we are talking about work. Okay, you want to break down work according to what? Okay, different activities, and then location, etc., etc. Okay, example, project. WBS normally consists of a few levels. Level 1, 2, 3, 4, 5. It depends. When you go down the level, it get more detailed. So you must have the reason why you want to put as much detail as possible. Sometimes it is not necessary. You can imagine writing your thesis, chapter 1. When you write your thesis, chapter 1, then chapter 1 is basically you have introduction, 1.1. Then 1.2, 1.3. That would be one level. Sometimes even 1.3, you might want to have 1.31. And then you detail out 1.3.1.1. So you can imagine why basically you want to split into those detailing. There must be a reason. So similarly, even WBS is like that. Okay, example, garage construction, as simple as garage construction. Garage, simple garage could have foundation, structural, roof, floor, external works. And then you split them. Foundation also do have a few works, earthwork, putting stump, structural element, lean concrete, column, beam, etc., etc., and whatnot. Okay. Dependency, logical relationship. When you draw something like this, A and then B, you remember if we draw it is as if it is on AON diagram. So the left side of the box indicates start, and then this is finish. And when the arrow is coming from the finish, so we call it this one is finish. Then when we go into the start, then automatically the relationship shown is basically finish to start. Finish to start is one type of relationship which is very common. Normally in the construction industry, we normally use this type of relationship. If, for instance, the activity basically follow very closely with each other, okay, interrelated activities. Then another scenario, A and then B. You notice that there is a gap here. Okay, there is a gap of time here. This gap of time, let's say, for instance, you pour concrete. This is slab. Slab. You pour slab, and then this is column. Next floor column. So logically, you cannot construct column immediately after you just simply pour the slab, the concrete. You need to wait for a few days. So this is like waiting period, waiting time, curing. And in scheduling, for PDM diagram, we do have what we call way to indicate, oh, the starting of the following activity might be delayed a little bit due to allowance on curing time. But for A and B in this situation, meaning to say B will start immediately. But for this situation, we want to show there is a so-called, the name is basically lag. We call it lag. Okay, we call it lag. Later on, we will learn about this, but that is the concept first. Okay, now we go into a different type of relationship. Okay, before we go into this, just remember AOA diagram basically just use the FS relationship. All the relationship is only finish to start. Okay, only this one. And then they develop AON. The initial AON only use FS relationship. So AOA and basic AON is very simple. But then come PDM diagram. When we talk about PDM diagram, I would say the enhanced version of AON diagram. Why? Because it does have 4 relationship. Number 1, finish to start relationship. Okay, finish to start relationship. You see how to draw this relationship. Remember, the left side of the box is start. The right side of the box is finish. And then the left side of the B is basically start, finish. That's why the relationship is finish to start, because it indicates where does the arrow is coming out from A and going into B. So the way you draw the arrow play very important part in understanding what type of relationship in a diagram. Okay, if you indicate different relationship and people read differently, then you will not get the answer correctly. For instance, if you solve one particular problem. Okay, number 2, start to start, or we call it SS. SS indicate, let's say A, when it's the arrow is coming from the left side of the box, it indicate S, start, and then it will go. When you draw arrow must have tail and head. This is what we call arrowhead. Otherwise, people do not know where does this thing goes. So let's say A is coming out from start and then go into B from the left side also start. So we call it start to start relationship. Meaning to say, both activities start concurrently or at the same time. And then third one is finish to finish. Finish to finish, you notice that it basically, the arrow is coming out from A from the right side, which is finish, and then go into B on the right side also. That's what we call finish to finish. Meaning to say, regardless of when does this both activities start, the most important thing is basically they finish at the same time. That's what we call finish to finish at the same time, because maybe the following activity, subsequent activity, let's say activity C, we'll have to wait for both of them completed concurrently or synchronized. And then number 4. Number 4 is the reverse of finish to start. Instead of finish to start and then start to finish, which I would say it is rarely used, but people do use this activity. I know that the real people basically use this activity. They for reason, okay, for a reason. So when you want to use activity, you choose the one that best suited your logical relationship. If you do not understand, then basically just use a simple one. Okay, later on we will demonstrate start to start, start to finish relationship. Okay, this is simply say activity A. If we want to start activity A, start, then activity B must be completed first. That is the kind of relationship which is quite rare. Okay. All right. Okay. How? Okay. Okay. I think we just go through a few more slides. Just want to show example. Okay. AOA diagram. Okay. Predecessor 1, 2, 3 is the activity that come before, and then successor is the activity that come after. Okay, that is the concept. All right. How do you read activity D, for instance, in AOA diagram? Okay, activity D will start only after A and B completed. Let's say A have 5 days, whereas B have 10 days. So when basically D will basically start or can start. Okay, for sure, even though A finish in 5 days, let's say A and B start at the same time, 0 days. 0 plus 5, A will finish in 5 days. Whereas 0 plus 10, B will finish in 10 days. So activity D can only start in day number 10, after day number 10. You see? So from this diagram, you can see that activity A basically do have some free time. 5 days is the equivalent of free time, where we might not start A at the beginning of the day. We can start A little bit later on. A can still catch up. Why? Because B will require a lot more time to complete. That's how the concept of critical activity and non-critical activity. I would say in this situation, B can be considered as critical activity, where A is basically non-critical. Non-critical and critical does not mean important or not important. Important or not important in our definition cannot be used, because all the activity must be important. Otherwise, they will be part of the building. Let's say you do not construct window, then what is the objective? Window is missing. Okay, and then lastly is basically dummy. Okay, what is dummy activity? Dummy activity is basically fake activity, or we call it imitation. Basically have zero duration. It is just used to indicate relationship. Okay, let's say I erase this dummy activity. Dummy activity is indicated by dotted line. How do I read C if I erase this one? How do I read C? C can only start after A completed. That's it. That is the way to read without the dummy. But once I draw dummy, dummy is there. Now, the way I read C is basically C can only start when A and B completed, because the dummy activity is there. But how about D then? D, even though the dummy is there, but D will start only after B completed. There is nothing to do with the dummy, because the arrow of the dummy is facing the other way around. Unless we draw the arrow facing this way, now D basically will start once A and B completed, both A and B completed. Then C got nothing to do with the dummy. So you see why dummy is being used to indicate relationship. And as I already mentioned, in order to draw this diagram completely without this D1, dummy 1, and dummy 2, then basically there is no way that you can draw in order to show people, because the drawing inside the arrow diagram must be interconnected. It cannot be just hanging around, just simply like that. Okay, so we stop at this one, okay, duration for this class. Okay, we stop at this duration.